Okay, I'm gonna split this office hours into two different sessions for this worksheet 11. The front is no calculator, and so I think I'm gonna actually save that for the second session because the first part of your test will be the graphing calculator test. So the whole front is no calculator. I'll do that after this. The back is graphing calculator. So I'm gonna start with that. Hopefully you checked your answers. Here they are real quick. Just the answers. Pause it if you need to. So I'm going to go over these problems now. These look similar to a lot of the problems we had on the pretest. And so for using your calculator to find secant, I usually say, okay, let's do cosine. Most of this is going to be in degree mode, your calculator, except for the sine regression won't be. So mode, I'm going to change it to degree mode. 1 over cosine 24 second angle degrees, 10 second angle minutes, and 3 alpha plus seconds. Sorry. Hit enter. 3 decimal accuracy, rounded or truncated, 1.096 is the same rounded and truncated. Okay, now this next one, I don't think we did one like this on the pretest, but this could be fair game on your test. So it says from 0 through 60 in DMS, if cosecant equals this and theta is not in quadrant 4, so this has a couple twists on it. DMS stands for degrees, minutes, seconds. So that means we want our answer in degrees, minutes, seconds, like the last angle was given to you. But there's a super easy way to do that on your calculator. But let's first focus on this. So cosecant is 1 over sine. So there's not a whole lot of room right here, but 1 over sine theta equals negative 1.5. So then that means that sine theta equals negative 1 over 1.5. Now I'm going to find alpha, which is inverse sine of positive 1 over 1.5. So let's see, I guess I could zoom in on this so you can see it better. So inverse sine, you need to be in degree mode, positive 1 over 1.5. And we get 41.810314. Okay, now what quadrants are we in? We're in quadrant, when sine is negative, that's quadrant 3 and quadrant 4. Now, usually we would give 2 answers. Like in the pretest, we give 2 answers, but it says not in quadrant 4. So this is going to narrow it down to 1 quadrant, quadrant 3. So the answer for theta in quadrant 3 is 180 plus alpha. So 180 plus your previous answer, 221.810314 plus 360K, which maybe isn't so necessary this time, but your final answer is 221.810 degrees. But here's the problem. You're asked to give it in degrees, minutes, seconds. So this is easy though. There's your answer right there, right? Go to the angle menu, go to option number 4, arrow DMS. That means change our current answer to degrees, minutes, seconds. It says, okay, you want to change the answer to degrees, minutes, seconds? Press enter. There it is. 221 degrees, 48 minutes, 37.134 seconds. I still want three decimal accuracy. So you should include those 3 decimals on the last one, even if I didn't on my solutions. I don't think I did on my solutions, but I would say this is more consistent with general directions. So that's how you do that. That's fair game on your test. Okay, solving triangles. I don't know if we had one exactly like that. Yeah, I'm not sure. But anyways, you should draw a picture just of a generic triangle. Maybe try not to make it look isosceles or equilateral or something special, just so that doesn't, Um, a lot of times I feel like it's helpful to put the one known angle right here, just in case it turns out to be ASS. Okay? So I think that's the best place for that. So little c would be over here. And then maybe one of the known side, at least one known side here. Well, that could be, little a equals 10. And that would be capital A. And then this would have to be capital B. And this would be little b. And little b is 9. So anyways, I just find it convenient to put the one known angle right there in that left kind of bottom corner. I feel like it just helps with ASS trying to figure out the height and all that stuff. But what situation do we have here? We have side, angle, side. So it doesn't even matter. Don't even need to worry about it. Now, we have to find angle A and the area of triangle ABC. Now, I don't know if we can find angle A directly first. I would set up a lot of signs. I'd say, all right, well, sine of A over 10 equals sine of B over little b, which is 9, equals sine of big C, which is 28 over little c. So look at that. Can we solve for anything there? No. So we have to use a lot of cosines. But I'm probably going to use this, so it wasn't a waste of time, and it made it very clear what I need to do. Now, if we're going to use a lot of cosines, we should definitely involve this angle they gave us, which means that the side across from it, it's going to have to be by itself over here. It's going to have to be the c squared, and then the others are going to have to be a squared plus b squared. The order of those doesn't matter. Minus 2ab cosine of the angle across from little c, which is big C, which is, I'll just write that for right now before I put any values in it. So that's the version of log cosines we're going to use. I don't memorize those. It's a pattern. So now we start plugging the values in. Okay. And we're going to take the square root of both sides, plus or minus. We're just going to do the positive. So that's 100. And let's just maybe try and write a nice 181 minus 180 cosine 28 degrees. Now, some of you guys are going to be like, oh, well, that's the same thing as the square root of 1 times cosine of 28 degrees. You can do 181 minus 80. No, you cannot do that. You're violating order of operation. So what is the decimal version of that answer? Let's see. Square root of 181 minus 180 cosine of 28 degrees. Make sure you're in degree mode. Is 4.697811. Okay, now that's not our answer, but we might need that for something. So now we can plug this back in up here for little c. Then we can find angle A or angle B. Now we've got to be careful because one of those could be obtuse, and if we do it on our calculator with inverse trig, it's going to give us an acute version, and we will have no clue. Now, so the better thing is to find the smaller of the two angles left and leave the last angle for the sum of the angles of the triangle up to 180. Okay? Now, if you don't do this and they happen to all be acute, then you get lucky and you get it right. But I'm still going to take off points. So remember the whole small, medium, large idea? That's what this is about. So I mean, if this was obtuse, then we could be like, who cares? Because we already know where the one obtuse angle is. Can't have more than one obtuse angle. But at this point, we don't know if there's any obtuse. Angle A would be the obtuse one if there was an obtuse one. So we got to find angle B first. So so angle B, I'm going to kind of do a little bit of work in my head. I'm going to multiply by 9 and take the inverse sine. Okay, so it's going to be 9 times sine of 28 degrees divided by the number we just calculated, 4.697811. You better use more than 3 decimal places in the middle of your work. Otherwise, you're in danger of losing 3 decimal actually for your final answer. So inverse sine of 9 sine 28 divided by, in fact, I can just divide by the previous answer. So I don't even have to type these in. Okay. And I get 64.080214. Okay. Now we can find angle A. Angle A is going to be 180 degrees minus angle C minus angle B. So 180 minus 28 minus 64.080214. And so that's 180 minus 28 minus the previous answer. Okay, use your calculator to help you not have to type all these in. And so we get angle A is 87.91. I'm just going to write the more accurate version right here, 87.919785. And this is going to be your final answer is going to be that. Now, rounded or truncated, you could do 87.920 if you rounded. Okay, that's one of your answers. Now, find the area of triangle ABC. Well, there's this special formula that maybe you've seen before for finding the area of a non-right triangle. I wouldn't bother with it because that's one more thing you got to memorize, and we could really just use what we already know to find this. The area of a triangle is 1/2 base times height, right? Now, I'm just saying, well, let's just make the base 9. Okay, that's easy. So all we got to do is find the height. Now, we've already talked about finding the height of a non-right triangle because we need to for the ASS problems. It's easy. Look, right here's the height. I would use this first known clean angle and this first known clean side. Okay, 9 is definitely not part of it. And do basic trig. So, okay, so, I mean, on your test, you got to make sure your work is just easy to follow and organized and stuff. You should have more room than this, probably. So, if you're going to find the height, show your work, write, if you're doing area 1/2 base times height, write down, make it really obvious. But the height would be sine of 28 degrees equals opposite h over the hypotenuse 10. So h equals 10 sine 28 degrees. So show me the exact values, and then we're going to put that in our calculator. And we're going to say, all right, well, 0.5 times 9 times 10 times sine of 28 degrees equals that. Now, I mean, we could give an exact answer too. We could say 45 sine 28. Simplified answer, but it's 21.126. And there are no units, so you don't need to put any kind of units there. So, okay. So you could easily have a problem like that on your test. Number 4, find the coordinates of a point in quadrant 4, 20 units away from the origin. And so they've given you a nice picture. If they didn't give you that picture, you would draw it. If cosecant theta equals negative 1.4, you're like, okay, well, theta is this theta right here. So let's see if we can solve for that. That angle. So cosecant is 1 over sine, co with a non-co. It's my trick for remembering it. So that means that sine theta equals negative 1 over 1.4. So I'm going to actually do, what I would do if I were solving this. I'd say, okay, well, alpha equals inverse sine of positive 1 over 1.4. And we're in quadrants 3 or 4, but obviously we're going to be working with the quadrant 4 one. So we're going to say inverse sine of 1 over 1.4 is 45.58469 degrees. And then quadrant 4 would be theta equals 360 minus alpha. So I'm just going to write that down and then do this on my calculator. So that's 314.415308 degrees. Okay, so that's the angle there. But really, I think alpha is probably what we want right here, because that's alpha. And we could create a right triangle, and the hypotenuse is 20. And so this would be the x-coordinate, and this would be the y-coordinate, right? This distance here is what x is, and this distance here is what y is. So I'm creating a little right triangle. I'm just going to use basic trig to find x and y using this angle and using this side right here, the hypotenuse. So I'd say, well, if I want to find x, I'm going to do cosine of alpha equals adjacent over hypotenuse. So x equals 20 cosine 45.58469. And sine of alpha equals opposite y over hypotenuse 20. So y equals 20 sine 45.58469. Now be careful, because what's going to happen here is that these are both going to come out positive, but we clearly know that y is a negative coordinate, so we should just put a negative in front of it, right? Make it negative, and maybe not wait just to make the final answer negative, because that doesn't quite just make sense in math to magically, put negatives here. So, anyways, 20 cosine 45.58469 is 13.997084, and 20 times sine of 40. Here's a cool trick. Second entry, copies and paste the previous one. We come up here and just put sine in, less typing. Now it's going to be negative 14.285714. Now we should write it as an ordered pair, I think, for a final answer. Final answer, x first, y second, 13.997, comma, negative 14.285. Ordered pair. That's not an interval notation. That's an ordered pair. So I don't know. You could probably find some other ways to do that, but that seemed like a nice straightforward way of doing it. If you rounded, it would have been negative 14.286. Okay. Number 5, vertical tree on a hill. I wonder if we're going to have one of those on our test. So we've got to draw a good picture here. And I try and draw this large because it gets real messy real quick. A vertical tree on a hill casts a shadow down the hill. Okay. 30-foot shadow down the hill. If the angle of elevation to the sun is 40 degrees, then what is the slope? Ooh, this is kind of a twist. We're trying to find the slope this time instead of like the height of the tree. I could ask you for the distance between the tip of the tree and the shadow, the slopes, the angle of elevation of the sun could be solved for. So let's figure out where the sun is by connecting the tip of the shadow and the tip of the tree. Let's draw horizontals at every angle. Okay. Now, it says angle of elevation is 40 degrees. So that's 40. This is 40. This is 40. This whole thing is 40. But then this is x. 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 So this angle right here is actually 40 minus x. And this angle right here is 90 plus x. So I'm going to draw a new picture that's a little cleaner, that only has the triangle. 30, 40 minus x, 90 plus x. Oh, this is going to be 50, 50. And we're trying to solve for x. X is the angle of the slope of the hill. So we got to find x. So I think that's all we have. Oh, 20-foot tree, by the way. So we do have that. It's 20. So what kind of, I'm probably going to want to solve for one of these angles and then solve for x. So I'm going to find this angle or this angle. So I'm probably going to do like a, side angle side, or angle side. And probably side angle side. It'd probably be better to just involve one expression with x's in it. But if we set up file signs, which hopefully works, but sine of, let's start with angles. We know 40 minus x over 20 equals sine of 50 over 30 equals sine of 90 plus x over, we're not sure what that one is. So I think we're going to use these two because we don't have all that information there. And we should be able to find x. So we're going to solve for the angle first. So we're going to multiply by 20, right? And then we're going to take inverse sine. So 40 minus x equals inverse sine of 20 sine 50 over 30. Okay? And so I guess we could go ahead and get a decimal for that. Now, okay. So inverse sine of 20 sine 50 divided by 30 equals 30.710220. And then we got to solve for x. Now, be careful. I mean, we could subtract 40, I guess. And that's going to be negative x. So 30 our previous answer, minus 40 times negative 1. So x equals positive 9.289, or x equals 9.290. Now, this is degrees. That's an angle. So there you go. Draw a picture. It's the same picture we've been drawing. We just ended up finding something a little different than we've been trying to. All right, concentric circles. That's a circle inside another circle centered at the same place. The circumference of the inside circle is 100 miles. The radius of the outside circle is twice the radius of the inside circle. So the radius of the outside circle I'm going to call capital R. The radius of the inside circle I'm going to call little r, just to make it more obvious. The radius of the outside circle, R, is twice the radius of the inside circle. So big R equals 2 little r. The arc length of the outside circle is 190 miles. Okay, and now we're going to try and find ACB, angle ACB. Now, I'm going to say that that's this smaller angle right here. So I'm going to put X right there. Okay, I'll clarify that on test day if you have any question. Is it this big angle, ACB, or is it the cute one? Now, I'm probably going to find the big one, actually, because it goes with this arc. So the approach I'm going to take is theta over 360. We're dealing with degrees, okay? So theta over 360, that would be this. Theta over 360 equals the arc length, S, over the circumference, 2 pi big R, all right? So theta equals, the big arc length is 190 over 2 pi big R times 360 degrees. So all we really need is big R. Now, to find big R, you got to find little r. And so we're going to have to take a little break right here. and find little r. Now we have the circumference of the small circle, 2 pi little r, is 100 miles. So that means that r equals 100 over 2 pi, or 50 over pi, which means that big R equals 2 times little r. So that's going to be 2 times 50 over pi is going to be 100 over pi, right? So now we're going to plug that in here and get theta equals 190 over 2 pi times 100 over pi. I don't think there's any reason to get decimals involved yet. I think they're actually going to make it harder. Because look, the pi's cancel out. Okay, unless you really have to. The pi's cancel out. If you keep it exact, it works out really nice. So, I mean, we could probably do this problem without a calculator. I mean, sure, you could use a calculator if you want, but this is going to be over 200 times 360. We could divide a 10 out of the top and bottom. We could divide another 10 out of the top and bottom. We had 2 out of 36 is 18. It's going to be 18 times 19. 8 times 9, 72. Carry the 7, 15, 0, 9, 1, 2, 14, 342. That's theta, but I want x. So x equals 360 degrees minus theta. So 360 degrees minus 342 is 18 degrees. That is our answer. Sure, you could use a calculator to help you with any of those calculations, but the answer came out pretty nice. Now, this doesn't mean it'd be like that on a test, but you're going to get something related to this kind of problem on your test for sure. And so it's about working from one circle to another, trying to get information from one circle so that you have the information you need for the other circle, and then also having to know how to calculate arc lengths. In this basic idea, it's not a formula to remember. It's an idea that the fractions of stuff remain the same. If this is a quarter of the angle, then the arc length is a quarter of the arc length, and the area is a quarter of the area. It's like the fraction just remains the same. We call that proportional. So, and you're going to have a trigger regression problem. So here's a problem. You're going to go to, so now one thing about this problem is that it's time, but it's an AM PM. So you have to add 12 to this and say 14, add 12 to this, 22, add 12 to this, this would be 20 and then 22. This is what you need to enter. If you enter the AM and PM times as AM and PM times, your calculator is not going to know the difference between AM and PM because you can't put that information there. So it needs to be in 24-hour time. So stat, edit. I got some stuff in here from before. Quickest way is to go to the top and hit clear. Don't hit delete. You'll just lose the whole list. So it's going to be 1, 4, 10, 14, 20, 22. Okay. Now, if you leave these AM and PM, one obvious result often is that you get a very short period and you get tons of waves in your graph, which probably looks a little weird. 45, 49, 56, 73, 65, 60. Okay, double, triple check them. You got to be exactly right. Otherwise, it's going to throw everything off. Now, so we got some upfront work to do. We're going to go to Stat, Calc, go to the bottom, Sign Reg, Enter. If it's in list 1, list 2, then you can just hit Enter. Otherwise, you can type them in, second number 1, comma, second number 2, and then hit Enter. But if you just hit Enter, it'll pick list 1, list 2 automatically. So I need this written down. Sign reg, y equals a times sine bx plus c plus d, which confirms you actually did sign reg. And then I need all these values, 13.17531,359. I need all the numbers to make sure I can check your answers when you get them wrong. B equals 0.2428620199. C equals negative 2.321247,002. D equals 58.376928. So I need this. You're getting credit for doing this. And if you do it wrong and you don't write it, then I can't give you credit for anything else because there's no way for me to check it. So we got that. Now, we should probably graph it. Probably the next thing. Okay, 1 day, so 24 hours. So we're going to go to window 0 to 24. The min, I mean, I might just put -1 just so I can see the x-axis. The max probably doesn't seem like it'd be more than 80. This is just a guess. And I'm going to graph it. Oh, nothing happens. Okay, that's because in the y, you haven't put your equation in the y. So instead of having to type it all in, we have this really cool trick, vars, number 5, statistics, equation, reg equation. Copies and paste it in. Now we hit graph. Oh man, something else is wrong. If it looks like this, something's wrong. It should look like a nice sine curve. Window, go to mode and make sure it's in radian mode. Now let's graph it. Okay, finally we get something that looks more like it. Now, like I said, if you did AM, PM, it'd probably be lots more hills and valleys. Okay, so let's draw a sketch of that. Maybe I'll try and leave some room for my derivative graph later. But this is pretty much it. 24. Okay, rough sketch. I need a sketch. Okay, and you should be writing on it. On what time intervals is temperature less than 60 degrees? So we're going to go in here and graph 60 and add that line to our sketch. So that's 60. So it says at less than 60. So those are open dots. Okay. But on the ends, that's like a solid dot because we're including the edges and they are definitely below 60. So we got to find those two points, intersection points. Second, calculate. Number 5, intersect. First curve, second curve. Guess. There it is. Write it down. I mean, 10.06642, comma 60. And we'll do it again. Second, calculate. Number 5, first curve, second curve. This is around 22 hours, maybe. It's quick way to do it instead of pushing over there. Pretty good guess. 21.98558, comma 60. Okay, so our answer, write our answer now. Temperature is less than bracket 0 to 10.006. 10.066, parenthesis, union, parenthesis, 21.985, comma, 24, bracket. Round is the same. What are the units? Hours. I need units. I will take off points for every answer you don't put units on these problems. What's the average temperature from 3 a.m. to 3 p.m.? Well, the way we do this is some work I need. Okay, is we're gonna integrate the function, which I'm gonna let you just generically write fx from 3 a.m. to 3 p.m., which is 15 hours, by the way. Be careful. Okay, that's gonna give us the total amount of temperature. Okay, so we do that on the graph here. We say 3 to 15, and it'll shade it for us. And if you want, you can kind of put that on your picture. That should hopefully, make sense. And the answer is 685.96198. Then we're going to divide by the number of hours, which is 15 minus 3, which is 12, right? Now, this is also the way you find the mean value theorem of any kind of function. You say, well, let's find the area under the curve, smooth it out, it's flat. That flattened edge is the average height, but it's also now like a rectangle that if you divide by its base, the area of a rectangle divided by the base of the rectangle gives the height of the rectangle. Divided by 12, this one actually works conveniently. If you do it from the graph screen, it'll use the value that you had. So the answer is 57.163 degrees. Okay, 3 decimal, actually, units, round truncated comes out the same this time. Find the time at which the temperature is increasing most rapidly. The temperature is increasing most rapidly. Now it looks like it's like right here. It's where you have the biggest positive slope. So we're going to graph the derivative graph here. Now some easy points to identify are the flat spots are going to be x-intercepts because their slope is 0. Then you're going to have a peak somewhere around here. You're going to have a valley somewhere around here. So I'm just kind of like getting a basic version of the graph real quick. So the way to do this is I'm going to get rid of that. Don't need that anymore. And then I'm going to go down here and turn this one on that I leave here just to make it a little faster. Or you could retype it. I mean, I'll get rid of it right now. The way you go is you go math, number 8, and derive on the home from the home screen. And then you do vars, y vars function y1 if that's where your function is, comma x always, comma, and usually this is where we put a number of where we want the derivative calculated, but we're going to trick it and put an x and it'll calculate it for all the x's. So if I graph this, it's probably not going to be a great graph. This graph's the original graph. You can kind of skip this step if you want and go directly to the nice graph. Now it's going to be down here, and look, it's really small. It's hard to tell. Like this is not very useful. So we really want to see this graph. So I'm going to go back to Y, turn this one off, and go zoom fit, and it'll fit the Y values for the only active graph in my list right now, which is that derivative graph. It takes a little while longer, but it's worth it. It gives you a nice view. You get the right answer. So I'm going to sketch it. And that's the biggest slope right there, biggest positive slope. So that's the increasing the most, and down here would probably be decreasing the most. Okay, and so I kind of predicted that the graph would look kind of like that, right? But this is what we're looking for. So we're going to do second calculate maximum, and it's not super clear to me which numbers. Left bound. So make sure you're to the left of it, right bound, and guess should be between the left and right bounds. There's the answer. So that's going to be 9.557899, comma 3.199783. And let's write this as a nice answer. Despite what I've written on my solutions, this is the way I want you to write. I want you to say the temperature is increasing most rapidly at a rate of, and so this is the rate, this is the slope, this is the derivative, this is the rate of 3.199 degrees per hour. You got to have 2 units. At time t equals 9.557 hours. I want units. I want a full explanation. What is the max or min? Where does it happen? Sometimes you're asked for one, sometimes you're asked for the other, sometimes you're asked for both. This is the safe way of doing it. I'm going to make you do it like this all year long. This could have been rounded to 9.558. This could have been rounded to 3.200 if you really want to round. But there you go. This is the kind of work I'm looking for. There's not necessarily a lot of work. I don't need the buttons that you push and stuff, but I do need sketches. I need the equations. I need correct answers. I need setups for integrals. Okay, there you go. Hopefully you're ready now.